Everyone, welcome back to my channel. Today, let's go over a medium question that I just solved a couple of minutes ago on my own. So I'm really happy about this. This one is called minimum operations to exceed threshold value 2. And I found that this one was a lot simpler than a lot of other mediums for some reason. So let's go over it. So you're given a zero indexed integer array called nums and another integer called k. So you're allowed to perform some operations on this nums array based on these conditions where either you can first select the two smallest elements from this array, delete them, and then push this value back onto the array. And then at any time, if all the elements on the array, meaning the smallest one, is bigger than or equal to k, then just return the result. Else, you can increment the result, and you just want to return how many times it takes to make the smallest element greater than or equal to k. So you can use a heap or priority queue, or you can use a sorted list, as I like to do it. And let's define a result we're going to return at the end because we're expecting an integer. And then again, you can perform the operation if there are at least two elements. So if the length of s is bigger than or equal to 2, then we can perform the operation. So at any time, if s of 0, which is the smallest one, is bigger than or equal to k, then we can just return result because we're done, right? So for example, 10, 11, 10, the smallest element is bigger than or equal to 10, happens to be equal to, so we just return result. Otherwise, let's call this a, is going to be s0. We're going to delete a from s. We're going to pop the second one, so it's going to be 2. So we just pop 1 because this is already sorted. And then this is going to be S0 again, delete S0 again. And then we're going to push back exactly what it says here. So new value equals to minimum of A and B times 2 plus the maximum of A and B. And then we're going to add new value. So insert it in exactly where it's supposed to be in sorted order. That's the beauty of a sorted list. And you keep doing this loop until there are less than 2 elements, or the smallest element is bigger than or equal to k. So let's run this. Okay, we forgot to increment result if this condition is not true in each turn. Let's maybe do this. Minimum of this times 2 plus maximum. Okay. Okay, so I don't know why this is not correct. Let's print A and B just to make sure. Okay. Oh, sorted list of nums. Sorry. This is going to be the sorted version of the list, so let's print S so you can see. Right, so that's what we have if we sort this in ascending order from smallest to greatest, left to right. And then we're going to pick the 2, delete them, and then insert 1 times 2 plus 2, which is going to be 4. So 4 goes back into the array, and then in whatever sorted order it's in. So let's print S so you can see. So 3, 4, 10, 11, because we deleted these 2. So we have this left, and then we insert the new value in sorted order where it's supposed to go. That's the beauty of a sorted list. And then you keep incrementing result. And then on the next turn, you do the same thing. You pop 3 and 4, and then you insert 10 because 3 times 2 is 6 plus 4, which is bigger than 3, is 10. And so you insert 10 back in there, and then this loop goes back, and now the smallest element, which is S0, because this is sorted in ascending order at all times, is bigger than or equal to k, so we can just return the result we found. So let's submit this, and output limit exceeded just means you have to get rid of the print statements. And there should work. There we go. So it passes all test cases. Not the most efficient, but I did come up with the solution on my own, and it's quite intuitive. So hope you enjoyed this video, and stay tuned for more.